All right, next one, substitution reactions. So substitution reaction, kind of like the name suggests, you are going to be subbing something in for something else. So you're going to take something out of the molecule and you are going to substitute something else into its place, okay? So two ways for you to recognize that it is a substitution. One of them is two compounds react to form two different compounds. Another way is that that carbon atom is still bound to the same number of atoms as it was before, right? So you think about addition and elimination, we were changing how many things that carbon was bound to, right? We were either adding things to it or we were removing things from it and creating double bonds. You're going to find when it comes to substitution, there's generally never any double bonds or triple bonds. Everything usually starts out as single bonds, okay? So when we look at substitution, there are definitely some specific requirements for these reactions to be able to occur. Some of them happen quickly, some of them happen slowly. What's going to determine that is basically what type of substitution and reaction are we looking at, okay? So we saw alkyl halides and alcohols were able to undergo elimination. They're also pretty common to undergo a substitution reaction. So what you find is that when an alcohol is reacted with a halogen, whether it's because it's like an HCl or like a Cl2, it's going to be able to undergo substitution, okay? Where the halogen is going to get swapped for that hydroxyl group. So basically what you're going to find, sorry, I'm just trying to move this over a little bit because it's over the writing. What you're going to find is that we can take something like this, which is an alcohol, and we can actually turn it into an alkyl halide, right? And if you look at what happened here, when I look at my starting molecule and I look at this final product, the only part of it that's actually really any different is that this hydroxyl group got swapped or substituted for this chloride or this chlorine right here, right? So if we look at what happened, we added HCl, right? So it had that Cl component. And then basically this Cl and this OH just swapped spots, right? And so now over here we have water because H with an OH is water. And now we have the chlorine in place over here. So what this does mean though is that we finally have some overlap in some of our types of reactions, right? So far everything was different, right? We were like, combustion, we're looking for plus oxygen. Addition, we're looking for a double bond or a triple bond in our starting molecule. Then we started talking about elimination. We were like, oh, okay, well, an alcohol in the presence of a strong acid. So here, HCl is a strong acid. So that means technically some reactions can fall under both the elimination and the substitution option. But what you're going to find is when it comes to like assessments, because things tend to be multiple choice or numeric response, only one of those two options is going to be present. The other one isn't going to be there. So I know sometimes you guys are like, well, what if they give me both options? How do I pick one? They wouldn't give you both, right? When it comes to multiple choice, you always want to think about the fact that there should only be one right answer. And if there's two right answers, then it's really not a valid question because a multiple choice should only have one right answer, okay? So yeah, we basically just substituted that, okay? The other option is to do the opposite, right? So now we're taking this alkyl halide and we're turning it into that alcohol, okay? We're doing that by adding a strong base, okay? So in this case, they just put in the hydroxide ion, but they also could have put in something like NaOH, right? And that would still have been the same because NaOH is going to immediately dissociate when we put it into solution to give us sodium, which would just be a spectator, and that hydroxide ion, which is then in place here. So this is why, once again, we have overlap because the elimination option was to have an alkyl halide with a strong base. This also falls under an alkyl halide with a strong base. That's why I was saying in the video on elimination that when you saw that sodium methoxide, it had to be elimination because sodium methoxide doesn't have this OH group like these two options do. So it can't actually undergo substitution, okay? So those are the first two types that can undergo substitution. We can take an alkyl halide and we can turn it into an alcohol by adding that hydroxide ion or sodium hydroxide, or we can take an alcohol and turn it into an alkyl halide by adding an HX or an HCl to it, okay, or an HF or an HBr or an HI. So the other types of things that can undergo substitution are alkanes. So they can undergo substitution, but it's generally not a very favorable reaction, okay? It requires a lot of energy. You can add in here that this reaction occurs very slowly. Okay, and generally it needs a catalyst. Without that catalyst, it's such an unfavorable reaction that nothing actually happens. So if you ever see that one of your starting molecules is an alkane, there's pretty much only two options of what type of reaction it could be. One is combustion, which should be pretty straightforward to recognize because it's plus oxygen, and the other one is going to be that substitution. What you're going to find, though, is for an alkane to undergo substitution, it's only going to work if you have an X2 molecule, right? So a Cl2, a Br2, an I2, an F2. It won't work for anything else. The other thing you're going to find is that even though there's two halogens in this X2, only one of them will ever sub into the molecule. It's not like both will go in, okay? Same thing you'll find is for aromatics, right? So if I have benzene, I can do a substitution on it, but same deal. It has to be that X2 molecule, and there has to be this catalyst. And just like with an alkane, like you can see here, even though those two bromines, only one of them actually got to go in. The other one stayed over here and paired up with the H, right? Because technically, again, even though it's not drawn in here, we do have H's. Yeah, there we go. At all of these spots, right? Because that gets our carbon up to a total of 4. So in this case, what they've done is they've taken the H from here and they've swapped this H with that bromine. Okay, and then that made that, that's an off layer, that made that HBr. And then over here now we have that bromobenzene. So sometimes you will see that they'll do multiple substitutions onto one of these, but what you'll find is, let's say I wanted to put on 2 bromines. Over here in front of this Br2, there would have been a coefficient of 2. And then there would be a second one in here, and I would have 2 of these HBr. And if, let's say I wanted to put 3 in, this would have a coefficient of 3. So anytime you're doing substitution on an alkane or a benzene, if you see that there's a coefficient in front of that X2, that's telling you how many of those X's you get to put in. No coefficient, you only get to swap one of them in, okay? Okay, so let's look at our first example. We have ethanol plus HCl. So ethanol means we have 2 carbons. Okay, there's an hydroxyl group on one of them because it's an ethanol. So that must mean that everything else has some H's on it. And then we fill in those extra spots that we have with our H's. Okay, again, those structural diagrams tend to be the easiest to figure out what is going on. You can do the other ones, but I find when you're not actually writing what's where, sometimes you guys get confused as to what you can take off and what you can't take off. So it tends to be safer to just do it this way. It makes it a little bit easier for you. Okay, so we have ethanol. We are combining it with HCl. Okay, so we're going to go through our little checklist, right? We're going to start with combustion. So there's no oxygen, can't be combustion. Then we go to addition. Well, there's no double or triple bond, so it can't be addition. And then we talked about elimination. We said for elimination, one of our options was to have that alcohol with a strong acid. So this does meet the requirements for elimination. Okay, so one of the options we have here is for this to undergo elimination. So if we think about what elimination means I need to take 2 things away so that I can create a double bond. We said you take the special thing away, so we're going to take the hydroxyl group off, and then off of the other carbon, we're going to take an H. right? So in doing that, we'll have just created water. And then we're going to have our molecule, which now has a few less things on it, right? It's now not going to have that OH or that one H that we took off, right? So it's just going to have this, where all of those represented H's. And then what we're going to have to do is turn this guy here into a double bond so that we actually have all of our carbons at 1, 2, 3, 4, and this carbon at 1, 2, 3, 4. So there's our first option, is elimination. Okay, then we have our other option. Our other option is to undergo that substitution like we just talked about. Okay, so substitution, because I have an alcohol and I have this HX molecule. Okay, so in this case, change the pen color over. What's going to happen is this OH is going to swap or substitute with this Cl. So they are going to switch spots. Okay, so now instead of having an HCl, we're going to have an HOH, which is water. And then we're still going to have this more or less same molecule. The only difference now is going to be, instead of having that OH group, we're now going to have that Cl. Okay, and then in all those other spots, we can fill them in with our H's. All right, so I filled it in with those H's. So now we look at it and we see how we made two different molecules even though we had the same set of starting materials. So over here, when we want to name this, here we just made an ethene, right? Eth, because 2 carbons, ene, because we have the double bond. Whereas over here, we made a chloroethane. Okay, so still eth because of 2 carbons, ene because in this case everything was single bond, and chloro because we have that 1 chlorine. Okay, I don't need to say that it's a 1 chloroethane because whether it was here or over here, that would automatically make that carbon number 1, so we don't actually need that number in place. Okay, so you do have to now start watching for the possibility of, is there more than one potential type of reaction that this could be? Because elimination and substitution have some overlap, and we have to make sure that we are watching for those, okay? All right, here's your next one. Chloroethane plus OH minus. So F, 2 carbons, oh, that's a C. There we go. A chlorine off of one of them, doesn't matter which one you are choosing. And then we're going to fill in with H's in those other spots. Okay, so we have our chloroethane plus that hydroxide molecule. We have 2 possibilities of what this could be, right? When we go through our whole list of potential options, we see that once again, this meets the requirements to both be elimination and to be substitution. So we're going to have to make sure that we show both of those possibilities. So when we are exploring elimination, we know we got to eliminate this guy, and then we have to take an H off of one of these ones, so we can take one of those off from here. So this H is going to pair with that OH, and that's going to allow for us to make water. Okay, that chlorine is going to come off. Normally it would go with whatever the cation is that's associated with this hydroxide, but because in this case we don't have one, we're just literally going to turn it into a chloride ion. Okay, then we're going to have the rest of our molecule. So everything in it stays the same, except for the parts that we just went about removing. Okay, so we have our H's that are in these slots here. Then what we're going to have to do, right, when we have a look at those 2 carbons that we have, they are now only each at 1, 2, 3 bonds. So just like we talked about before in elimination, we're going to fix that by turning that single bond into a double bond, okay? So here, we just went and made ethene. Okay, in the substitution option, right, things are a little different. So in substitution, this OH is just going to swap spots with that Cl. Okay, so now what we're going to find is we are going to have that chloride ion, right, because it's now taking the spot of that OH, and that OH is now going to take the spot of that Cl, right? Again, remember we talked before about how when we are putting that OH at the start of the molecule, we are going to write it as HO instead, and we do that to make sure that we are showing that it is the O that's attached to the C, not the other way around, okay? Because we can't have hydrogen being attached to two things. It just doesn't work. It only wants to be attached to one. Okay, we fill those hydrogens in that we have on the top, and then we do the same down here on the bottom. Okay, and then we want to go ahead and name this. When we look at this, we have 2 carbons, so it's an F. In this case, it's also an alcohol. There's nothing else that needs to go into the ending, so this is going to be ethanol, right? So again, like I mentioned before, I do want to make sure that you're feeling pretty comfortable with the naming and drawing of molecules before you jump into types of reactions. Otherwise, it just becomes too much unknown all at the same time, okay? All right, and then here's our last example that we're going to do. We're going to look at benzene plus bromine with that catalyst, okay? So we think about what benzene is. We have our hexagon, and look at that, I'm drawing a lovely hexagon instead of my usual hexagon. And then, because it's benzene, well, that circle's not quite where I want it, but I'll move it. Remember, we put the circle into the middle of it, right? And that indicates that we have those alternating single double bonds. So again, even though it's not indicated, we want to make sure that we are aware that in each one of these spots, we have a hydrogen, okay? So we put those in. Okay, so we tack those in. Again, normally we don't draw them. It just makes it, excuse me, a little bit easier to see what is happening when we actually include them, right? So we are adding bromine to that. We have our catalyst in this case, so this reaction can happen. No catalyst, it won't happen. And it also has to be an X2. No X2, nothing will happen. So if you ever see that you have a benzene with nothing else happening, and you want to try to do substitution, you have to make sure that you have the bromine and that you have the catalyst. Both of those requirements need to be there. So once we see that we have all the pieces that we need, we then can draw out what this is actually going to be, right? So we're still going to have our benzene. Okay, but now what's going to happen is one of these H's, doesn't really matter which one you can pick any one you want, I'm just going to pick this one, is going to swap spots with one of those bromines. So that means now over here, in this spot, we are going to tack on that bromine. Okay, I'm not going to draw all the other H's just because it's time consuming, but they are there, right? They are implied because this is a line diagram, so I don't need to show them, but I do need to show that bromine because it's not an H, right? And then our other product is going to be that HBr, right? The H because we took an H off, and then a Br because we had that leftover bromine from that Br2 molecule that we added in. Okay, so that is what your substitution looks like, right? It can either be an alcohol turning out to alkyl halide, or it could be an alkyl halide turning into an alcohol, or it can be an alkane or a benzene undergoing that substitution with an X2 and a catalyst.